We've spent time looking at different types of exponents. In this lesson, we're going to take a look at a few different types of examples where you can utilize those skills. One type of question that comes up is a question involving a rate of growth or decay. So this is what we call an exponential equation because the exponent is a variable. If we have an exponential equation, usually that variable represents some unit of time. The base on that power is the rate of growth or decay. So if we see a 2 here, that usually indicates that we are doubling. If we see a 3, we're tripling. If we see 1/2, it's usually a half-life. And this number here that's being multiplied by the power is the number of items that we have to start with. In each question involving variables, they're going to tell you what does each of those variables represent. So in this case, B is the estimated number of bacteria that we have. H is the time in hours. So you could even go to the side and just kind of make a list for yourself so that you remember which is which, and then figure out what you're looking for. So in this case, we're looking for how many bacteria. So this is the variable that we are going to have in our equation, which means they're probably going to give us a number that we're going to substitute into that equation for H. H is the time in hours. So in the first question, we want to know how many bacteria were present after 3 hours. So 3 hours, because we're dealing with time in hours, and you have to watch your units. In this case, we can just substitute 3 in the place of H, and then we can enter this in our calculator if you want, but 2 to the power of 3 is 8. 8 times 400 is 3,200. So this is how many bacteria we could expect to be present. After 24 hours, you can substitute 24 in the place of that H, and then this one you probably do want to put in your calculator, and when you do that, we end up with 6,710,886,400 bacteria we would expect to be present. And then 3 hours ago, so this is 3 hours prior to the start time, so what we're going to do is put a -3 into that equation, and so now we have 400 times 1/8, and that's going to give us a value of 50. Each of these numbers is a rational number, and it represents the number of bacteria that are present. And if we start with 400 bacteria and they're growing, they're doubling every hour, it makes sense that 3 hours ago we had less bacteria than the amount that we originally started with. Let's take a look quickly at another bacteria question. So in this particular one, we know that this is the starting number 10,000, and they do tell us in the question that we have 10,000 bacteria to begin with. We have a 2 here, which means that we are growing. We're going to be doubling because this is a number bigger than 1, and our exponent is H over 42. So that particular number of bacteria, this is the rate at which they grow. So we know that this 2, the base of the power, tells us that rate of growth or decay if it's less than 1 but greater than 0. So in this case, 2 tells us those bacteria are doubling every hour. That's the unit of time that we're told for this particular question. So if we want to know how many bacteria are present after 42 hours, we can substitute in the place of that H, and then 42 divided by 42 is just 1. So we have 2 to the power of 1, which is 2 times 10,000. There are 20,000 bacteria. We have a rational number. The next question wants to know how many more bacteria are present after 2 hours. So we can substitute 2 in the place of that H, and this time when we put this in our calculator, we're going to have 10,000 times 2 to the power of, and then you're going to go in your calculator bracket, 2 divided by 42, close that bracket, and we're going to end up with 10,335.57, etc. So we get an irrational answer. We want to know how many bacteria that is more than what we started with. So we're going to subtract 10,000 from this amount, and we're going to have about 335 more. Now, I didn't round up because that last little bacterium is still in the process of being formed, technically. And then in the last one, we want to know how many bacteria are present after 105 hours. So we can substitute 105 in the place of that H. We can enter that in your calculator. So again, 10,000 times 2 to the power of, bracket, 105 divided by 42, close the bracket. We get another irrational answer. And even though this is a 5, I didn't round up just because that last little bacterium is still being formed. So I just kept it as 56,000 568 whole bacteria we would expect to have. And then in our last exponential equation, we're told that in 2010, there were approximately 34 million people living in Canada. So if we take this 34 million people, write it in scientific notation, that's what they've put here. So this is the starting number of people that we have. This is the unit of time, and we can see this is the rate of growth because we have a value greater than 1. We are growing at 0.9% per year. So if we change percent into a decimal and then multiply by the starting amount, we're taking that 0.9% of the original amount that we had. The reason we're multiplying by 1 is because when we multiply by 1, we preserve that original number. So we're going to take this amount, we're going to multiply by 1, which keeps that 34 million, and then we're also going to grow by 9%, which as a decimal is 0.009. All right, so we want to know what is the projected population in 2018. And again, watch your units here. So P is population, N is the number of years. Our starting point is 2010. So in 2018, we are 8 years later. So we're going to put in an exponent of 8, 3.4 times 10 to the power of 7, times 1.009 to the power of 8, and try this on your calculator to make sure you can enter it correctly, gives us 36,526,515 and 74 hundredths. We cannot have a part of a person, so we are going to have to round this. Because we're looking at the projected population, I did follow the rounding rules. Because the number after that 5 is a 7, I am going to bump that up and say that we would project to have 36,526,516 people. B is similar. Now we want to know what is the projected population for 2021. So take our formula. 2021 is 11 years after 2010. So we can put an 11 in for the exponent, enter that into the calculator, and again, because we're looking at the projected population, I followed the rounding rules. This is a 2, so I did not change that 4. I left it as a 4. And then what was the population in 2000? So this is the formula for 2010. 2000 is going to be 10 years before. So we're going to enter a negative 10, which means that we end up with less people than what we started with, which is what we would expect. And you can do a little bit of research here. So what is the current population in Canada? How close was it to what we projected it to be in any given year? And what are some of the factors that would affect the rate at which a population grows? In our next question, we're given a cube. So we know it's a rectangular prism where the length, the width, and the height are all the same length. We know that we can find the volume of a rectangular prism by just multiplying length times width times height. But if the length, the width, and the height are all the same length, we can just multiply the side times the side times the side, or the side length cubed is a quick way to get the volume. So we're going to start with that formula, and we're told that the volume is 360 cubic centimeters. So I know that I'm dealing with volume because of the units here. I'm going to substitute that 360 in the place of the volume, and we are looking for the side length or the length of that edge. So now if we have to isolate S, we have a cubed. We can get rid of that cubed by cube rooting, and what I do to one side, I have to do to the other side. So on the right hand side, when we cube root a cube, it's going to cancel out, leaving us just with that S. And then in our calculator, we're going to enter the cube root of 360, and we're going to get 7.113, etc. Now, this is not like a person. We can have a decimal for an edge, and it doesn't tell me what to round to in this question. So I'm going to leave it as an exact value, but we do have to make sure we put units on it. So because the volume is given to us in cubic centimeters, then the length of each edge will be in centimeters. So we're going to end up with an edge length of 7.113, etc. centimeters. And in our last question, we have a pendulum. The length of that pendulum is 6 feet, and we have a formula to calculate the period of that pendulum. So the period is just the amount of time it takes to complete one full swing. So there and there, that's one full swing out and back. The first thing you want to do when you're given a formula is to look at the variables and to make a list of what they represent. So we can see that T represents the period, and the period is measured in seconds. L is the length, and the length is measured in feet. feet. So we're just going to make note of that. Pi is not a variable. So pi is a constant. That's a specific number, 3.1415, etc. And then what we're going to do is figure out what we're looking for. So in this particular case, we are looking to calculate the period, which means t is the variable we're trying to solve for. And that's good news because it's already isolated. We don't have to rearrange the formula, which means they're going to give us the L. And in this case, we know the L is 6 feet. So we're going to begin by substituting that into the formula. And then because this is already isolated, we can just enter that into our calculator. We're going to begin with the square roots. We're going to go second function and then squared to get that square root. And then because we need to tell our calculator to calculate the entire numerator before we divide, we're going to have to put this in brackets. We're going to go bracket 4. We have to use the value for pi in your calculator, which is right on top of that exponent key. So we're going to go second function and then press that exponent key to get the pi. Don't enter 3.14. That's not exact. We want the exact value. And then squared, and then we're going to go times 6, and then you need to close your bracket on the numerator. So we're going to get the entire product, and we're going to divide that entire product by 32. And then you can right arrow out of that square root sign if you need to, and then we're going to press enter, and this is an irrational number. So in this particular question, we are asked to round to 2 decimal places, which is to the nearest hundredth. So what we're going to do is take a look at what is in that hundredth position, and it is a 2. Look at the number after. If this number after is a 5, 6, 7, 8, or 9, it's going to bump this up. If it's a 0, 1, 2, 3, or 4, this is going to stay the same. So we round this off to 2.72, and you have to include the appropriate units. So period is measured in seconds, so we need to put seconds on our answer. And clearly this is not drawn to scale. This is obviously not going to be 6 feet. It's just the best picture I could find.